Hello everyone, we are from Group 1 Section 1 for the subject site investigation. In this video, we are going to propose our solution for the slope failure located at Maran District, Pahang. The slope failure caused the existing road premix to collapse. Other than that, damages of drainage system at the area were also found. Our group members consist of 4 members, which are Joshua Lampun Anak Cakap, Sarinata Simon, Valerin Vun Meishan, and Su Ka Won.
Firstly, soil cement backfill as the base for the cabin wall. The bottom of the soil that are excavated is compact with a vibrating plate compactor. Then, backfill the first layer of the soil cement and compact the soil evenly. Next, continue to backfill the next layer and compact the soil. The steps is repeated until you reach the height of 5 meters. Lastly, make sure the base is level from back to back and side to side.
Procedure for constructing cabin wall. First, cabin basket will arrive by pallet network in flat pack form. Unpack your basket and fold the sides together, leaving the lid open. Then secure the 4 corners of the basket with the tie wire supplied. Next, we will continue with site preparation. Ensure that the earth to be returned is terraced for safety while construction takes place. Excavate the area in front of the earth to be returned to a depth of 100 mm and then lay and compact a suitable surface material such as taphole. Baskets are placed and secured to one another using supply tie wire or heliocals. Bracing wire is used to prevent the basket bulging. The face of the basket should be hand-laid to create a dry stone wall effect. A further press is added to prevent bulging of the basket. The lids are closed and secured using tie wire. The process will be repeated for the top layer of the cabin wall. The membrane is used to cover the rear of the basket before backfilling can take place. And finally, the cabin wall is complete.
Drainage system. As we can see in the figure, the process of removing water that has accumulated on the surface of the land is known as surface drainage. A surface drainage system should include land smoothing or grading and is made up of shallow ditches that run across the landscape. The rate at which water is removed from the surface by surface drainage is dependent on a number of interrelated factors, including the amount of precipitation, the characteristics of the soil, and the patterns of cropping if there are vegetation. Before beginning the process of designing a surface drainage system, topographic survey of the area and create a contour map of it should first be conducted. This can be accomplished through grid surveys, laser techniques, photogrammetric methods, or some combination of these. As a record of these permanent improvements, make sure to keep copies of the contour maps as build plans and profile drawings. These resources will prove to be extremely useful in the future when it will be necessary to regrade the channel or reshape the ditches. For the subsurface drainage, are using horizontal drain hole were utilized to discharge groundwater flowing down inside of a slope and groundwater flowing out of a slope. Casing pipes are typically made of hard polyvinyl chloride pipes, also known as PVC, or gas pipes that have an internal diameter of more than 40 mm. In order to collect the groundwater, the casing pipes must either have their section that traverse the aquifer perforated or the pipe must have its entire length perforated, because a rigid pipe cannot accommodate the landslide movement that is occurring in an area without separating at the joints. Rigid pipes should not be used in an unstable area or in an area where there has been a landslide. Gabions are used to create an outlet protection system for horizontal drain holes. In the absence of outlet protection, erosion brought on by the accumulated water will be active and lead to the collapse of the outlet.
For the innovation of our gabion wall will be implementing vegetation to the gabion wall. Gabion walls can be designed to support vegetation either by incorporating soils and plants into the wire mesh cages or by attaching a vegetated facing to the wall. This can not only improve the aesthetic of the wall but also increase the stability of the wall over time. Incorporating vegetation into gabion walls can have several benefits. Some of the benefits are increased stability, where plants and roots can help to hold the soil in place and increase the stability of the wall over time. This can be especially beneficial to gabion walls used for erosion control or slope stabilization. Other than that, vegetation can improve aesthetics. Vegetation can make gabion walls more visually appealing and can help to blend the wall into its surrounding.